In this video, we're going to talk about the area between two different graphs. So we're looking at a graph of a parabola. Parabola is y equals x squared plus 2, and the line y equals x. And we see a shaded region that goes from -1 to 2. So if we wanted to try and calculate this area, we could possibly approach this by taking it and breaking it up into regions that we do know how to find the area of. And the shaded region blue here is represented by the definite integral from -1 to 2 of our parabola. And we know how to calculate that. Our antiderivative is 1/3 x cubed plus 2x, and we're going to evaluate it from -1 to 2. And plugging 2 in, we get 8/3 plus 4. And plugging -1 in, we get -1/3 minus 2. And so when we subtract those two results, which is 8/3 plus 4 plus 1/3 plus 2, we're going to get an answer of 9. And that represents the blue shaded region. However, that blue shaded region is not the area we're looking for. In fact, it's a little bit bigger than our shaded region. It's precisely bigger by this red triangle. So we're going to want to subtract the area of that triangle from our total. We can just use geometry here. It's going to be 1/2 times the length of the base times the height of the triangle, which is an area of 2. So we're going to subtract 2 from that result. But while we're now a lot closer, we still don't have our shaded region because we're going to want to include this purple region here. And so we're going to add the area of that. Again, we can use geometry. 1/2 times the base of the triangle times the height of the triangle. That has an area of 1/2. So we're going to want to add that to our area, giving us a total area of 7.5. However, we might want to see if there is a way to approach this problem where we do not have to break it up into multiple regions and kind of combine these shapes in different ways. So let's set this problem aside and let's look at an alternative approach. So I've given us 3 graphs, and what I want to do is I want to shade the region represented by each of these definite integrals. F of x is the downward facing parabola as labeled here, and the region from A to B is shown here shaded purple. Moving on to the second graph, we have g of x, which is labeled as this upward facing parabola. And from A to B, we have this region shaded red. Now, the second problem, we're told to find the area underneath the curve f of x minus g of x. Well, this would produce some new function, but that new function is not graphed. However, if we remember that we can break this up into 2 different definite integral problems, the first being the definite integral of f of x from A to B, and the second being the definite integral of g of x from A to B, then we'll recognize a way in which we can represent this set of regions in the shaded area above. Subtracting those 2 shaded regions is going to leave us with the region that lies between the 2 parabolas, taking what was in purple and removing the part that was red. This idea is going to give us a new approach to our problem above. So let's return and see if we can apply this new idea and get the same result. We have 2 functions here. We have our top function here, which we could call our f of x, and we have our bottom function, the line, which we can call our g of x, and we can do from -1 to 2 the difference between our 2 functions. We were given these 2 functions in the original problem, so we can set that up as the definite integral from -1 to 2 of f of x, which is our parabola, minus g of x, which is our line. Now let's solve and see if we get the same result of 7.5. So we get 1/3 x cubed plus 2x minus 1/2 x squared, and we're going to evaluate from -1 to 2. So first we'll plug 2 in, and we're going to get 8/3 plus 4 minus 2, which is 8/3 plus 2, or 14/3. That's plugging 2 in. Then we'll plug in -1, and we're going to get -1/3 minus 2 minus 1/2. And let's get a common denominator of 6. So that's -2/6 minus 12/6 minus 3/6, giving us a total of -17/6. And we want to subtract our two results. So our area is going to be equal to 14/3 plus 17/6. Again, we're probably going to want to get common denominators here, 6 and 28, giving us a result of 28 plus 17, 45/6, or 15/2, which is in fact 7.5. So this gives us a way to calculate the area between two different curves. If I want to know the area between f of x and g of x, then I can do the definite integral from a to b of the difference between the two functions, making sure that I put the top function first and I subtract the bottom function. Here are two practice problems for you to do. Try these two problems using this new approach to finding the area between two curves, and we're going to talk about them when we come together for class on Monday.